Explain question number 24, exercise 6.5, class 12th. Show that the right circular cone of least curved surface and given volume as altitude equal to root of 2 times the radius of the base, means that the relation is find out the altitude is root of 2 times into the radius. So their least curved surface is find out and volume is given, means volume is constant. So solution start. Let r and h be the radius and height means altitude of a cone respectively. The volume v of a cone is v is equal to 1 by 3 pi r square h is equal to 3v upon pi r square. The surface area s of a cone is s is equal to pi r l is the s length. Height s is equal to pi r root of r square plus h square, because the s length and height and base is make a right angle, and here Pythagoras theorem is apply. So h is equal to s length in means length, l is root of r square plus h square. So pi r root of here h value is put, so r square plus h square, so is h is equal to 3v upon pi r square whole square, so is apply here 9v square upon pi square r power of 4 is equal to pi r root of here inside the common LCM is take pi square r square and take outside, so is pi r square. So pi square r power of 6 plus 9 v square is equal to 1 upon r root of r square root of pi square r power of 6 plus 9v square. Here pi to pi cancel and r to r cancel, that's why 1 upon r is remaining. Differentiate with respect to r, so ds upon dr is equal to, here u upon v formula for differentiation is used. V means r dot differentiation of root pi square r power of 6 plus 9v square, so 1 upon root 2 root this, so 2 root of pi square r power of 6 plus 9v square inside the bracket differentiation. So pi square is constant, r power of 6 differentiation is 6 r power of 5, so is 6 pi square r power of 5, and 9v square is constant, so differentiation is 0, minus differentiation of v means r is 1 and this term is as it is, so minus of root pi square r power of 6 plus 9 v square upon v square means r square. So here in the numerator take the LCM is root of pi square r power of 6 plus 9 v square, so is equal to, here 2 divided to 6 is 3 remaining, so 3 pi r square and 3 pi square r power of 6 minus this is root multiplied to this, so is root of remaining is minus pi square r power of 6 minus 9v square upon r square root of pi square r power of 6 plus 9v square is equal to, here is this term to this term is minus, so remaining is 2 pi square r power of 6 minus 9v square upon r square root of pi square r power of 6 plus 9v square. For find the relation between r and v, so if ds upon dr is equal to 0, then this term is equal to 0, so 2 pi square r power of 6 minus 9 v square upon r square root of pi square r power of 6 plus 9 v square is equal to 0, so this term transfer to this side, so it's 0, so this term is transferred to this side and minus 9 v square transfer to this side, so 2 pi square r power of 6 is equal to 9 v square, so r power of 6 is equal to 9 v square upon 2 pi square. For find the d2s upon, again dr upon ds differentiate with respect to r, so d2s upon dr square, so is equal to, here u upon v formula is used, So first r is square take constant and the differentiation, so r square root of the v term is take constant, so r square root of pi square r power of 6 plus 9 v square, bracket of this differentiation is 2 pi square is constant and r power of 6 differentiation is 6 r power of 5, so 6 into 2 is 12 pi square r power of 5 minus this term is as it is, so minus bracket of 2 pi square r power of 6 minus 9 v square into differentiation of r square root of pi square r power of 6 plus 9 v square. So first this differentiation and this as it is, so r square division to r root of pi square r power of 6 plus 9 v square plus here r square is constant and differentiation of root this, so 1 upon 2 root of pi square r power of 6 plus 9 v square, here inside the bracket differentiation, so pi square is constant, r power of 6 differentiation is 6 pi 6 r power of 5 and 9 v square is constant, so differentiation is 0 upon r power of v square, so r power of 4 bracket of pi square r power of 6 plus 9 v square, at r power of 6 is equal to 9 v square upon 2 pi square, then d2s upon dr square is greater than 0. If this relation is put in this equation, definitely this is greater than 0, so this condition is minimum, least condition means minimum value condition. So by second derivative test, the surface area of the cone is the least at r power of 6 is equal to 9 v square upon 2 pi square, at r power of 6 is equal to 9 v square upon 2 pi square, so put this value, put in h is equal to 3v upon pi r square, so here v value put to this relation, so is equal to 3 upon pi r square bracket of 2 pi square r power of 6 upon 9 power of 1 by 2, so is equal to 3 pi r bracket of root 2 pi r cube upon 3, so is equal to here pi to pi cancel, 3 to 3 cancel and r square to r square cancel, so remaining is root 2 into r, means h is equal to root 2 into r, that relation is find out. Hence for the given volume, the right circular cone of the least curved surface has the altitude 2 root 2 times the radius of the base, that is the solution.